So in this video we're going to integrate square root of x squared plus 9 with regards to x. Now in this video I'm going to do something called a trig substitution, and that's one of three methods we can use to try and solve this function. So this is my technique number one for this same integral. So this same integral, I've got three methods. Check the link in the description below, you'll see the other two. So first of all, let's look at the method I'm going to use for this one. Now for a trig substitution, I want to substitute my x for a trig function that will work with a plus sign and a 9 at the back. So when I square something to get 9, I want a 3. So I'm going to let my x equal 3 times tangent theta. So that's going to be my substitution. So now what I need to do is to take my derivative of both sides. So now my derivative of x will give me dx, and derivative of 3 tangent theta is 3 secant squared theta. So that's a standard derivative for tangent. Okay, so now what do I need to do now? Let's substitute this all into this integral here and see where that takes us. So now my integral becomes x squared plus 9. Well, x squared will be 9 tangent squared theta. So now I've got 9 tangent squared theta plus 9. And then my dx is 3 secant squared theta. So now I've got 3 secant squared theta, and that will be d theta. So if I put my d theta there just to be 100% correct. Okay, now let's simplify this up a little bit and see where that takes us. So this I can factor out a 9, and I can bring the 3 out to the front. So that's what I'm going to do next. So 3, that's that 3 there. Inside my square root I can factor out a 9. So I've got 9, and then I'll have tangent squared theta plus 1 inside my bracket. So that will be the equivalent for that. And I've still got secant squared theta sitting at the back here. Okay, now tangent squared theta plus 1, there's a good trig identity for that we know. So tangent squared theta plus 1, that's just secant squared theta. So that's a trig identity there we can plug in for this one. And also we've got square root of 9 here multiplied by the square root of tangent squared theta plus 1 essentially. So we can bring the square root of 9 out and put that as a 3. So now I've got 3 times tangent squared theta plus 1 is secant squared theta. And then I've got another secant squared theta still on my outside. Okay, now we can simplify this. The 3 can come out the front, so I'll multiply that, and then the square root of secant squared theta, well, they're just going to cancel out, and I'll have another secant theta. So now I've got 9 times the integral of secant theta times secant squared theta d theta. Okay, well, now I can just multiply these together, and then we can use the power reduction formula for secant. So let's have a look at that. So 9 secant cubed theta d theta. So with my substitution, this has become this. Okay, now my power reduction formula for secant. Well, the integral of secant to the power of n theta, that just becomes, so I've got n minus 2 over n minus 1, and then that is integral of secant to the n minus 2 theta d theta. So that's my first part of my power reduction formula. And then the second part, which is not an integral, I've got secant to the n minus 2 tangent theta, and that there is theta. Let me just write that a little bit clearer. So that's that one there, and then what I do, I divide that by n minus 1, and this bit is added on. So here I've got secant cubed theta, d theta, multiplied by 9. So essentially if I put a 9 in front here and let my n equals 3, I've got my solution. So what I need is for n equals 3. So apply my power reduction formula. So power reduction formula, that's on this step here. I've now got 9 times. So n minus 2 over n minus 1. So 3 minus 2 is 1, 3 minus 1 is 2, so that's a half. So I've got 9 times 1/2, and then an integral secant n minus 2. 3 minus 2 is 1, so it just leaves me with secant theta d theta. So that's my first part of my answer. And then now, out of the integral, so that's not in the integral, I need to add, and again, my 9 is my constant multiple, so that applies to this part as well. And then I've got secant to the n minus 2 theta. Well, n is 3, it's just secant theta. So I've got secant theta, tangent theta. So they are multiplied. And then divided by n minus 1. So 3 minus 1 is 2, so that's a half. So that's my power reduction formula enclosed in this part here. Okay, now let's just clean this up a little bit. So now I've got 9 over 2 integral of secant theta d theta, plus here I've got 9 over 2 as well. So here I've got 9 over 2, and I multiply that by secant theta tan theta. Okay, so that's what I need to do now. This is my integral I need to solve, and this is part of my answer. So what I'm going to do now, I'm going to clear this off the board, bring this up to the top, and let's continue trying to get our answer. Okay, so this is where we're up to for now. So this will be part of my answer. I now need to solve this integral. Well, secant theta, the integral of that is a standard integral. So secant theta d theta, that's just the natural log of the absolute value of secant theta plus tangent theta. Okay, so now let's plug that all into here. So now I've got 9 over 2 secant theta tangent theta. So here I've got them multiplied, here I'm going to have them added. So sometimes that's just how it goes. 9 over 2 times the natural log secant theta plus tangent theta. Okay, now I'm not ready for my plus c yet because I'm still in the theta world here at the moment. So I'm going to bring it back to the x in a little while. So let's have a look at this. So if x equals 3 times tangent theta, then I've got tangent theta equals x over 3. Now I've got a tangent theta here, so that's x over 3, and that will be x over 3. So let's plug that in. So 9 over 2 times secant theta times x over 3. So what I'm going to do is here now, I'm going to put this as 9x and then multiply that by 3, secant theta. That will be part of the answer there. And then here I've got plus 9 over 2 natural log secant theta, which I'm going to come to in a minute, and then tangent theta, which is x over 3. Okay, so now I want to find out what secant theta is. I want to put that in terms of x. Now I've got nothing here really where I can transfer that back, except for, we know it's a trigonometric substitution. So why don't we just draw a triangle? So draw a right angled triangle. Now tangent equals opposite over adjacent. So that is x over 3. So we know that. So let's draw an angle in here. So if we let that angle be my theta, I've then got x over 3. So opposite will be x, adjacent will be 3. So this side is x, this side is 3. So then by Pythagoras, just making sure we know that's a right angled triangle because we're into trig, this hypotenuse will be the square root of these two sides squared. So then I've got square root of x squared plus 9. Okay, now secant, let's just write that here, secant theta is the same as 1 over cosine theta. Now cosine theta, we know that is adjacent over hypotenuse. So therefore secant is the reciprocal of that, which equals hypotenuse over the adjacent. Now the hypotenuse we've got there, that's the square root of x squared plus 9, and my adjacent one is 3. So that there is my secant. So where I see secant, I can just plug in this value here. Okay, so now let's plug that in. So 9x over 6, so I've got 9x over 6 multiplied by square root of x squared plus 9. So square root of x squared plus 9, and then divide that by 3. And these are going to be multiplied together. Okay, now with this one, add 9 over 2 natural log secant theta I can now plug in. So square root of x squared plus 9 over 3 plus x over 3, and that's my absolute value. Still not finished, I'm not going to put my plus c in there just yet. Just simplify this one off. Well, 6 times 3 is 18, 9 over 18, that's just going to give me a half. So I've got a half, and then x times square root of x squared plus 9. So what I'm going to do here now, instead of writing 1 times that, I'm just going to put that into my fraction. So now I've got x times the square root of x squared plus 9. So that will just become that. So that's, I'm happy with that. So now this one. So plus 9 over 2 natural log. Now here I've got x squared plus 9 over 3 plus x over 3. So I'm going to factor out inside my absolute value 1/3. And now I can put a bracket and just write these two x terms in there. So now I'm going to write this as square root of x squared plus 9 plus x. And then that takes care of all of that. And then now I can close off my absolute value. And then all you do now is do my plus c. So if I put plus c there, I'm happy with that as my answer. So that's my first way of doing this integral. X times square root of x squared plus 9 over 2 plus 9 over 2 times natural log of 1/3 of square root of x squared plus 9 plus x, all in absolute value, and then plus c.